What's up, guys? Welcome back to another video, and today we'll be talking about derivatives and the limit definition of a derivative. And so essentially, you might be wondering to yourself before you even clicked on this video, or if you've already had experience with a derivative, what a derivative might be and what does it mean? Well, derivative in short answer is just slope. It is just a very long and complicated word that just stands for slope. And so remember how in Algebra 1, maybe Geometry Algebra 2, you learned about how to take y2 minus y1 over x2 minus x1? It's similar to that, the limit definition of derivative. And so essentially, a way that I can put it into words or y'all can form, a visual in your head. Let's use the function that we used last time. F of x is equal to 2x. You know how this function looks like. Now, you might be wondering, what will be the derivative of this function? Well, you might be confused as to what derivative is. Essentially, the derivative is literally just that. It's literally just the slope at any point in a function. Or if you're trying to find derivative, or if you're trying to find a specific derivative, then you might, do that too. But essentially, for f of x is equal to 2x, the derivative would just equal 2. Because if you can see throughout the whole function, you can see that the function is always increasing by 2, no matter which point you put it in. So, like rise over run, boom, 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 it's always by 2. But how can we find that through calculus? And here is where the limit definition of a derivative comes in. So as we talked about limits, limits the last time is just going in through a point, at a specific point, and through that you're able to find what's happening around that specific point. So essentially, the limit definition of a derivative is just a limit, and this is pretty confusing, so keep that in mind. As h approaches 0, f of x plus h minus f of x over h. And so this is just the equation used to find the limit definition of a derivative. And so you might be wondering where this is described. Well, to be honest with you, I have no idea where it's coming from. And I can make that a separate video, if you want to understand the why or like the how, where it comes from. But overall, the best I can tell you is that the h just represents the point where it's getting closer and closer to the graph. So let's say you had like a random function. My best approach would be that the h represents how close it is, how close x is, and then how close h is. But then since h is approaching 0, we can say that it's nearly the same thing. That's nearly the same thing, and you're finding the limit. You're finding the slope of the limit at that specific point. So that's how I would approach it. Again, I can always make another video showcasing the history and how to like actually transcribe it, if you're wondering. But overall, this is the equation that we'll be using as the limit definition of a derivative. And so we're going to see it in action. So let's say you had your f of x is equal to 2x, right? Now, you might be wondering, well, we know that the derivative is 2, or the slope is 2, but how can we show this? Well, here we go. So limit as h approaches 0, f, and remember, you're putting everything in the x. So I'm sorry, instead of the f, it would just be 2x plus h minus f of x, which is just equal to 2x over h. So from here, we can see some properties already of distributing. So we will do that immediately. So then we just distribute the 2 to the 2x plus 2h minus 2x over h. And from here, just like any simple equation, we just try to simplify and reduce to as much as we can. And we can see here that the 2x minus 2x just equal to 0. So then we're just left with 2h over h. And from here, we can also see that both h's simplify. So from here, we're just left with limit as h approaches 0 of 2. And if you saw my other limit video, you would know that the limit as anything that approaches to anything of any constant is just the constant itself. And so through calculus, that's how we can find how f of x, 2x, and how we can find the derivative. And pay attention to this part. The notion of a derivative is f prime with the little apostrophe on the top. I don't know how you call it. F prime of x is equal to 2. And so that's a way to find it through calculus, or through limits, and that's how we call it the limit definition of a derivative. And so we'll go through one more example. Remember your equation? Let's change it to purple. Actually, no, let's change it to blue. So just write down your equation. And let's say you had f of x is equal to x squared plus 2x. Let's just say you had those. Now, essentially, what you're going to do is just the same, but this time, you're going to replace everything with the x plus h. And so here's what I mean. So we know that f of x is equal to x squared plus 2x. All you're going to do is just replace everything. So this might seem a little confusing at first, so pay attention. For the x squared first, all we're going to do, since our function is f of x is equal to x squared plus 2x, we're just going to replace the x with x plus h in every single x that we see. So essentially, it'll be limit as h approaches 0 of x plus h squared plus 2x plus h, then minus f of x. And remember, distribute that minus everywhere if you don't want to get confused. So from here, we just bring down our function. And then we square double squared. If you remember that from algebra 2 or pre-cal, we square double squared. So we square the x squared. Because essentially, x plus h is just x plus h. If you square it like that, you get 2 x's, x squared. You get hx or xh, and you get 2 of them. Then you get h squared. So square double squared. Plus h squared. And then from here you can distribute. So you have plus 2x plus 2h minus x squared minus 2x all over h. This is pretty long, so bear with me. So then you have limit as h approaches 0, and then you just combine like terms. So as you can see here, we can see that the x squared, they just become 0, and then the 2x, they also just become 0. So you have to pay attention to that. So from here, we're left with 2xh plus h squared over h. And you might be wondering here, well, let's add in the zeros. Well, don't do that, because then you just get 0 over 0. Don't do that. And if you're wondering why, well, if you put 0 into any of the h's, you will just get 0, because 0 multiplied by anything is 0. And so from here, you might be wondering, well, how do we simplify this even further? Well, from here, what we're able to do is just like in the last video when I had x squared minus 1 over x minus 1, we're able to factor out a variable from this. And the letter we're able to factor out is h, because we have 2xh plus h squared. And so h is the greatest common factor, I believe. So you can just factor out the h. So you're left with h times 2x plus h over h. So from here, you can just simplify the h's. And so from here, you're left with limit as h approaches 0 of 2x plus h. And then from here, you're actually able I'm sorry, it seems like I forgot the plus 2h. And so this is why you don't do anything without looking at the full picture. Oh my God, I forgot. I really forgot that, huh? So you have to add in the plus 2h, obviously. So disregard this other word. You can see how I messed up, right? Don't do this. Look at the full picture and see what you're working with and say it out loud. So now that we have the plus 2h, because I knew something was missing, I knew it. But we have 2xh plus h squared plus 2h. If you want to rearrange that in from like order, you're more than able to. So from here, it is still the same thing. We can see that from here, we're able to simplify or take out an h from everything because it's the greatest common variable. So what you're left with is an h 2x plus h plus 2 all over h. And same thing applies here. You're still able to simplify. And then limit as h approaches 0 is just equal to 2x plus h plus 2. And now from here, you're able to put in the 0. And as you can see, what we're left with is 2x plus 2 as your derivative. So f of x is equal to x squared plus 2x. Then we can safely assume that f prime of x is equal to 2x plus 2. Now, there's a method to gain the answer really, really quickly for my next video because I already knew the answer in like 5 seconds. Actually, less than 1 second. Not being arrogant. Not I'm being arrogant, I'm being cocky. But you might be wondering, well, how about rational functions? How can we find the derivative of a limit? And before I go on, this is essentially just saying that the f prime of x, or the derivative, if you put any point in there, you will find the exact slope, which is what it's saying, is essentially. Because if you remember from our function x 2x, we can see how everywhere you go, the point is just 2, which is why it was just a constant. But with higher level functions like x squared, x cubed, x to the fourth, you'll get these crazy functions where you're able to have different points and different derivatives depending on the point that you put into. So that's why we say this is the limit definition of a derivative. It's not exactly at a point, but if you were to put in a point, you would get the exact derivative at that point for that specific function you're trying to find. So we're gonna do one more. We're gonna do f of x is equal to 1 over x. So if you want, just write down your equation. And then from here, we just put in our function. So we have limit as h approaches 0, and this time 1 over x plus h minus 1 over x over h. So if you remember from Algebra 2, I believe, on how to subtract rational functions, add rational functions, you know that in order to make this equation come true, we have to, what we're going to have to do essentially is we're going to have to, multiply the denominator with everything. And so what I mean by that, well, since we need common denominator, we're just going to multiply the 1 over x by x plus h all over, and then we're going to multiply by x right here as well. So we're going to have x minus x minus h all over x times x plus h. And so from here, you're just able to cancel out with the x's, so that just becomes 0, and you're just left with negative h over x times x plus h. And then from here, in order to actually cancel that out, what we can do is we can just have negative h and then just distribute the x squared to everywhere. Just trying to take over my work. Always take over your work with rational functions because they're kind of difficult. So I was just looking back over my work, and it turns out I actually forgot to put the h underneath everything. So again, these are just some of the mistakes you have to avoid because this is obviously a very, very difficult topic. But from here, all you're able to do is just limit as h approaches 0 of negative h over x squared plus xh. And then from here, you can just keep change flip. So you just keep the original function, as you can see here, flip it, and then you just get 1 over h. Then you can simplify the 1 over h to just be negative 1. Then from here, which has limit as h approaches 0 of negative 1 over x squared plus xh. So then from here, since you don't have anything that's going to turn to a 0, you can safely put the 0 in for the h, and then you're just left with negative 1 over x squared. So that'll be your derivative. So we have f of x is equal to 1 over x, then f prime of x will be negative 1 over x squared. And so this is a quick introduction to limit definition of a derivative. Obviously, this is a very, very difficult topic because I had to take my work a lot of times and I even made mistakes throughout this video. So, this is just, a raw natural way to see, progression. Because even for me, this is still difficult because I still have to understand, the complexity of it. But even throughout the mistakes, I really hope y'all enjoyed this video. I tried to be the best as I can. And hopefully I liked the video. Thank you for watching. Please like and subscribe. And if I made a mistake somewhere, tell me where I did so I'm able to, refocus, give me some feedback, please. And thank you for watching and goodbye.